Today, we're going to build an AI-powered image recognition app in Python. By the end of this video, you'll have a desktop app that can look at any image and tell you what it sees, just like a real-world object detector. And don't worry, I'll explain everything step by step, including all the code. If you see a picture of a dog, your brain immediately identifies it as a dog. However, computers do not naturally understand images. To a computer, an image is simply a grid of numbers representing colors and pixel intensities. Artificial intelligence allows us to bridge this gap. By using deep learning models trained on massive data sets, computers can learn patterns that allow them to recognize objects visually. In this project, we build a simple desktop application that allows a user to upload an image. Once the image is uploaded, the program sends the image into a trained neural network model, which analyzes the image and returns predictions about what object it believes is present. To build this project, we combine several important technologies. We use Python as the programming language, TensorFlow for artificial intelligence computation, EfficientNet as the deep learning model, Pillow for image processing, NumPy for numerical transformations, and tkinter for creating the graphical desktop interface. Go to the terminal and make sure these modules are all installed. Now, let's walk through the system step by step. At the top of the script, we import tkinter. Tkinter is Python's built-in graphical user interface toolkit. It allows us to create application windows, buttons, labels, and other visual components that users can interact with. Next, we import the file dialog module from tkinter. This module allows the application to open a file browser so that the user can select an image from their computer. After that, we import image and image toolkit from the Pillow library. Pillow is responsible for handling image files. It allows us to open images, convert their color format, resize them, and display them inside the application window. Next, we import NumPy. NumPy is extremely important in machine learning applications because neural networks do not process images directly. Instead, they process numerical arrays. NumPy converts our image data into a structured array of numbers that the neural network can interpret. Then we import TensorFlow, which is the deep learning framework that powers the artificial intelligence component of this project. From TensorFlow, we specifically import EfficientNet B3. EfficientNet B3 is a powerful convolutional neural network designed for high-accuracy image classification tasks. This model has already been trained on the ImageNet dataset, which contains millions of labeled images across more than 1,000 object categories. We also import two helper functions: preprocess, input, and decode predictions. The preprocessing function prepares image data so that it matches the format used during model training, and decode predictions converts the model's raw outputs into readable object labels. Next step is loading the artificial intelligence model. In the code, we initialize the model using EfficientNet B3 with ImageNet weights. This means we are loading a pre-trained neural network that already understands thousands of visual patterns. When the program runs for the first time, TensorFlow loads this model into memory. During this process, you may see several messages appear in the terminal. These messages are normal. They often mention CPU optimizations such as SSE, AVX, or FMA instructions, and sometimes they mention 1DNN operations. These messages simply indicate that TensorFlow is configuring itself to run efficiently on your computer's processor. You may also see a message explaining that GPU acceleration is not available on native Windows installations of TensorFlow. This does not prevent the program from working. It simply means that the neural network will run on the CPU instead of a graphics processor. Phase 3 is defining the image recognition function. We are going to create a function called recognize image. This function contains the entire pipeline responsible for analyzing an image. The first step inside this function is opening a file dialog. When the user clicks the upload button, this dialog allows them to select an image from their computer. So, If an image is selected, the program proceeds to load it using the Pillow library. Then, in this step, we are going to convert the image to RGB format once it's opened. This step is critical because neural networks expect images with exactly 3 color channels: red, green, and blue. Next, the image is resized to 300 by 300 pixels. Efficient NetB3 requires this specific resolution because that is the size used during training. Now, at the same time, we create another slightly larger version of the image is prepared for display in the application window so the user can clearly see what image was uploaded, which will then displayed in the interface using the Image Toolkit module so that tkinter can render it inside the window. Let's continue. Now we need the machine to convert the data to machine-readable numeric. The resized image is converted into a NumPy array. This transforms the image into a matrix of numbers representing pixel intensities for red, green, and blue color channels. Next, the pre-processing function is applied. During the original training of EfficientNet, images were normalized in a specific way. The pre-processing step ensures our image follows the same normalization process so that the neural network interprets the data correctly. Now, the most important part. The processed image array is passed into the neural network using the model's predict function. Inside here, the image moves through many layers of computation. Early layers detect simple features such as edges and color contrasts. Deeper layers identify patterns such as textures, shapes, and object structures. After processing the image through all layers, the neural network produces a probability distribution across more than 1,000 possible object categories. To make the results understandable, we use the decode predictions function to convert these identifiers into human-readable labels. Now, the program extracts the top 5 predictions with the highest confidence scores. Each prediction contains a label and a probability value. The probability is converted into a percentage so that users can easily interpret how confident the AI is about each prediction. The program then assigns a reasoning description based on the confidence level. If the confidence exceeds 80%, the system describes it as a very strong visual match. If it exceeds 50%, the system interprets it as high similarity. If it exceeds 25%, it is considered a possible match. Anything lower than that is described as a low confidence guess. This reasoning layer makes the results easier to understand because it translates raw AI probabilities into human-friendly explanations. Well, now that the image recognition logic is complete, the final part of the program focuses on building the graphical user interface using tkinter. The first step is creating the main application window. This is done by initializing the tkinter root object. This root object acts as the main container that holds every visual element of the application. Immediately after creating the window, the program sets the title of the application. Next, the window size is defined using a geometry configuration. In this case, the application window is set to a width of 520 pixels and a height of 600 pixels. After the window is configured, we begin adding visual elements to the interface. The first element added is a title label. This label displays the text AI image recognition. Below the title, the program creates a button labeled Upload Image. This button is the main interaction point for the user. When the user clicks this button, the Recognize Image function is executed. This function opens the file dialog and begins the image analysis. Finally, another label is created to display the prediction results generated by the AI model. This label is configured to use a readable font and left-aligned text so that the prediction list appears organized and easy to read. Now, once all interface components are created, the program starts the tkinter event loop. This loop keeps the window running and continuously listens for user actions such as button clicks or file selections. With the event loop active, the application remains responsive and ready to process image recognition tasks whenever the user uploads a new image. Hope we have no internal conflicts. Let's run our code and upload images for predictions. This is just a simple and non-accurate result prediction due to AI models and computing power. But this is the same flow of core pipeline used in real-world computer vision, such as medical image analysis, autonomous driving, and security surveillance. And once you understand this pipeline, you can extend the project further by adding features such as live webcam recognition, object detection with bounding boxes, or deploying the model as an online AI service. Thank you for following this tutorial and exploring the fascinating world of computer vision. Stay creative, keep building, keep inventing. See you in the next video.